Bismillahirrahmanirrahim. Assalamu alaikum, boys and girls. Welcome back to another new lesson of distance learning program. Boys and girls, we have been doing a new lesson called area and volume of similar figures. In yesterday's class, we started with the areas of the similar figures. That was exercise 12A of your maths book 3. Today in continuation, again, we will be doing some more questions. And about yesterday's lesson, it was a bit longer lesson, so my humble apology. And I really sympathize with you guys that you guys are doing a great job. Watching all those subject lessons weekly, daily is a great job. And I salute you guys. Okay, you guys are doing a remarkable job. So um, hopefully today this lesson will be a very short lesson and you'll enjoy it. So here we go. So my dear students, as you all know, my name is Sayyid Faraz Hassan and I am your mathematics instructor. With me, I have my team of subject specialists, Sir Ashraf Ali and Miss Shabana Salman. So, my dear students, our learning objective for today, by the end of this lesson, you will be able to solve the problems using the relationship between areas of similar figures. Let's have a quick recap of what we have learned yesterday. We have learned that the ratio of areas A1 upon A2 equals to square of the ratio of their corresponding lengths. The ratio of areas of the two similar figures equals to the square of the ratio of their corresponding lengths. Or you may also write it this as A2 upon A1 equals L2 upon L1 whole square. Both ways are absolutely okay. This is up to you, but make sure when you have area A2 in numerator, on the other side the length L2 should also be in numerator. Likewise, in this case, when you have A1 in numerator, so you will also have L1 in numerator. So let's start our today's. So boys and girls, this is exercise 12A, sorry, exercise 12B from your maths book 3, and this is question number 9. So two solid cones are geometrically similar and the height of one cone is 1.5 times that of the other. Given that the height of the smaller cone is 12 centimeters and the surface area is 124 centimeters square, find the height of the larger cone and the surface area. So dear students, as there are no figures given, so for our own understanding, we can draw two cones. This is a smaller cone. This is a bigger cone. Now, uh, height h1 of the smaller cone, height h2 of the larger cone. Now, what are they saying about this? The height of one cone is 1.5 times the height of the other. Given that the height of the smaller cone is 12, so h1 is 12 and height of the other cone is 1.5 times 1.5 times that of the other. So 1.5 times 12. So we can use our calculator. 1.5 multiplied by 12. So the height of h2 will be 18 centimeters, right? Now, what else are they asking? Given that the surface area of the smaller cone is 124, find the height and the surface area of the larger cone. The area of this one is the surface area A1 is equals to 124 centimeters square, and the area of this cone is required, the larger cone. Okay, so we have the height h1 of the first cone, the height h2 of the other cone. We have the area a1 of the first cone, and we need to find out the area a2 of the other cone, that is the larger cone. So we'll be applying the same formula, a1 upon a2 equals h1 upon h2 the whole square. Now, height is also a kind of length, right? We have learned the formula a1 upon a2 equals to l1 upon l2 the whole square. So height is also a kind of length. We can replace l1 and l2 by h1 and h2. So let's plug in these values which have been given to us. 124 upon a2 equals h1 is 12 and h2 is 18 the whole square. So you can simplify the bracket. 6 2s are 12, 6 3s are 18. Furthermore, you have 124 upon a2 equals the square of 2 is 4 and the square of 3 is 9. So in order to calculate a2, you can do the needful cross multiplication, a2 on this side, 9 on this side. So we have 124 multiplied by 9 equals 4a2. Now, what is unknown? A2 is unknown. We'll bring back 4 on this side and divide by 124 by 9. So we have 124 multiplied by 9 divided by 4. This is equals to A2. Now you have your calculator, boys and girls. You can calculate it by using your calculator. 124 multiplied by 9 divided by 4. So your answer is found to be 279 centimeters square. So I hope this makes sense to you guys. We have simply applied the same formula, that is a1 upon a2 equals to l1 upon l2 the whole square. So let's do the next part of the question. Okay, so there is no other part. We have found the first part, the height. So this is the answer of the height. That is, height h2 is 1.5 times the height of the smaller cone. 1.5 times multiplied by 12, you can see here. So your calculator will give you your answer. 1.5 multiplied by 12 equals to h2 is equals to 18. This is the first answer. Then we need to find the total surface area. So we're going to apply the formula of area A1 upon A2 equals to L1 upon L2 the whole square. We replace L1 and L2 by H1 and H2. We plug in these values and we simplified it, and we found the surface area of the larger cone is 279 centimeters square. Okay, let's move on to the next question now. All right, this is question number 11. And in this question, boys and girls, they are saying in the figure MN is parallel to QR. We can see two arrows with the lines MN and QR. The arrows clearly indicates that the two lines are parallel. If the area of the triangle PMN and trapezium MQRN are in the ratio 9:16, find the ratio of the length MN ratio QR. Now, my dear students, just read the question very clearly. If the area of the triangle and the trapezium MQRN, now look at this. This is a triangle, this is a trapezium. I'm underlining it and I'm giving you 5 seconds to think about it. The first one is the triangle PMN and the other one is the trapezium MQRN. Do you think a triangle and a trapezium are similar? No, they are not at all similar. Triangle contains 3 sides. Trapezium contains 4 sides. How can they be similar? So we haven't learned any formula about the resemblance, similarity between a trapezium and a triangle. So we need to go for some similar figures. We need to think about how to make some similar figures. So look at the data. The ratio of the triangle and the trapezium are in the 9. If this is 9 and this is 16. So first thing, you need to identify a pair of similar triangles. How are you going to do that? So I'm writing it here. Triangle PMN similar to triangle P, Q, and R. Can you see this? Triangle P, Q, R. Now we have 2 similar triangles. So the area of the small triangle PMN A1 is equal to 9, and the area of the big triangle, that is PQR, will be the sum of 9 and 16. 9 plus 16, that is equals to 25, right? Okay, now we have the areas of the 2 similar triangles PMN and PQR. Now by this understanding, we can calculate the ratio of the unknown parallel sides MN and QR. So applying the same formula which we have learned, A1 upon A2 equals L1 upon L2. What is L1? L1 is MN and L2 is QR. All right, boys and girls, I hope this makes sense to you guys. So now let's plug in these values which have been given to us. 9 and 16 was given to us. I added 9 and 16. I added this triangle and trapezium so that I found a big triangle PQR. So the area of the big triangle will be 9 plus 16. That is 25. So A1 is 9, A2 is 25 equals MN and QR. So we need to find out these ratios. Okay, now, dear students, if you put some light on these two fractions, 9 upon 25 equals to mn upon qr whole square. Can't you see that both the sides are exactly the perfect squares? 9 is a perfect square, 25 is a perfect square, and this side contains a square on top. So you can simplify it by taking square root on the 2 sides. What can you do? Take square root on the 2 sides. Take square roots both sides. All right, so 9 upon 25 equals mn qr whole square. So I'm taking a square root on this side, I'm taking a square root on this side. Square and square root, they cancel out each other. I'm continuing it here on this side. So the square root of 9 is 3. The square root of 25 is 5 equals mn upon qr. So what did they ask? Find out the ratio mn ratio qr. So therefore required ratio mn qr equals 3 ratio 5. This is the required answer. I hope this makes sense and the concept is very much clear. If not, you can comment on it and I'll help you out. So this is the right answer, 3 ratio 5. What have we done? We have added the values of a triangle and a trapezium to get a big triangle, and we named it as A2, A1 was already given to us as 9. We applied the formula A1 upon A2 equals to L1 upon L2 the whole square. We plug in these values, simplified it. We found both the sides are squares. So how do we get rid of the squares? By taking square roots. So I took square roots on the two sides, simplified it, and I found my answer Mn ratio QR equals to 3 ratio 5. So my dear students, this is the end of the class today. So what we have learned how to solve problems using relationship between areas and similar figures. And again, we have simply used the concept ratio of areas of the two similar figures equals to the square of the ratio of their corresponding lengths. Hope you have learned this formula by now. So thank you, dear students. Attempt the homework right after this lesson for a better understanding. Now, I'm not giving you any homework, but I'm sure your respective class teachers, they have been giving you homework. So please do that homework ASAP, right? So leave a response. Thank you all students who have been continuously commenting on my lessons. I really appreciate you take out time and do comment on it. So have a nice day. Take a good care of yourself. See you next week. Until then, Allah Hafiz.